So hello everyone, let us solve another LeetCode problem, and the problem name is magic squares in grid. So let us read the problem first. So a 3x3 magic square is a 3x3 grid filled with distinct numbers from 1 to 9 such that each row, each column and both the diagonals all have the same sum. Now given a row cross col grid of integers, we need to find how many 3x3 magic square subgrids are there. And also they have given a note that while a magic square can only contain numbers from 1 to 9, but the grid may contain up to 15. So this is the problem, and if you look at the constraints of the problem, it is pretty much smaller. So this is just an implementation based problem. We just need to implement according to the rules of the question. So first of all, let us see the first example to understand the question in more better way, and then we will see how we can implement this particular solution. So this is the example 1, and the output for this example 1 is 1, that is only one magic square grid is present, and that is none other than this particular grid, this 3x3 grid. So this is the magic square grid which is present in this example 1, that's why it is output 1. Now how this is a magic square grid, let us understand with this example only. So this is the first row. So first condition is that each and every element in this square grid should be unique and it should be from 1 to 9. So let us check. 4 is coming one time, 3 is coming one time, 8 is coming one time, 9 is coming one time, 5 is coming one time, like 1 is coming one time, 2 is coming one time, 7 and 6 is also coming one time. And if you look at these numbers are between the range 1 to 9, both included 1 and 9 in the range. So okay, this condition is fulfilled. What is the second condition? Second condition was of the sum condition, like the row sum, the first row sum, second row sum, the third row sum, the first column sum, second column sum, third column sum, as well as the sum of these diagonals, both of the diagonals, they should have the same sum. So first of all, we need a base sum from which we can compare like what is the actual sum that we need to keep track of. So we can just check the first row sum. The first row sum is nothing but 4 plus 3, that is 7, 7 plus 8 is 15. So the sum for each and every row, each and every column and both the diagonal should be 15 only. So let us check whether this scenario gets fulfilled or not. So let us see the first row. The first row sum is 4 plus 3 plus 8, that is 15. So yes, this row matches. Second row sum is 9 plus 1, 10, 10 plus 5, 15. So okay, this row is also matching the sum. The third row, 2 plus 7, 9, 9 plus 6, again 15. So this row also matches. Now we will check for the columns. Now for the columns, 4 plus 9 is 13, 13 plus 2 is 15. So okay, this column matches the sum. Now the second column's turn. So its sum is 3 plus 5, 8, 8 plus 7 is 15. So okay, this also matches. Now the last column, 8 plus 1, 9, 9 plus 6 is 15. So okay, this column also matches. Now we need to take care of the diagonals. So this is the first diagonal, 4 plus 5, 9, 9 plus 6, 15. So okay, this diagonal also matches the required sum. Now we need to check this inverted diagonal. So 8 plus 5 is 13, 13 plus 2 is 15. So okay, our summation condition is also fulfilled. So that's why this grid, this particular 3x3 grid is a magic grid. So that's why we are returning the output as 1, because we find only one grid which is a magic grid. So yeah, this is what the question is actually trying to say. Now let us understand how we can implement this solution with this example only, so that we know what all things we need to take care and how we will proceed with this solution. So let us see now. So yes, this is the example 1. So what we are doing, first we are calculating the number of rows and number of columns. So what we can do, for a top left element we will see whether we can create a 3x3 grid or not, because forget about the other conditions like row sum, column sum, diagonal sum. If we are not able to create a 3x3 grid, then obviously we cannot check other conditions as well. So first condition must be whether we can create a 3x3 grid or not, because it is not possible that for every top left element we can create a 3x3 grid. So keeping this as the top left element, we can create 3 cross 3 grid like this. Okay, so we will be keeping track of the top left element with I and j pointer, I for row and j for column. So with this we can create. Now let us see for this particular I and j. So now this is the top left element. Can we create a 3 cross 3 grid? Yes, we can create a 3 cross 3 grid like this. So okay, now we will move forward. Now we will be having the top left element as this, which is 8. Now can we create a 3 cross 3 grid? We got 3 rows, but we couldn't get 3 columns. So with this top left element we cannot create a 3 cross 3 grid. So the first condition is that whenever we are running a loop for I equal to 0 up till I less than n and I plus plus, and there will be one internal loop which will be for the columns for j equal to 0 till j is less than m and j plus plus. We need to restrict this loop. Why? Because this particular I and j range will take each and every element as the top left element for the 3 cross 3 grid, but we know that we cannot create with every top element a 3 cross 3 grid. So there will be a restriction on this range. So what can be the restriction? Now if you look at this, our I is let's say our I is here, I and j is here. Now the number of row is 3 and number of column is 3. Now why we are able to create a particular 3 cross 3 grid with this particular top left element? Because if we do plus 3 in row and column both, we were able to be within the n and m range. If we are here, this is the top left element. If you increment your j with plus 3 and I with plus 3, we were within this n and m range. So that's why we were able to create a 3 cross 3 grid. Now if we are at here at this particular position, if you do like 2, this is the second column and this is the 0th row. So if you do 0 plus 3, that is equal to what? 3, which is within this range of columns, the rows. But if you do the second column plus 3, you will get the summation as 5, which is not within the range of our columns. So we need to restrict it. And what will be the restriction? Restriction will be nothing but from 0 up till I is less than equal to n minus 3. So let me just rewrite this entire condition. So what will be the range for these loops for which we can try the element as the top left element for this particular 3 cross 3 subgrid? So the condition will be from I 0 till I is less than equal to n minus 3 I plus plus. Also for j is less than equal to m minus 3 j plus plus. So within this range only we need to check whether a particular grid is a magic grid or not. Now if it is a magic grid, if is magic, this will be the boolean function. We will be passing grid, will be passing ith row and the jth column. This will be the top left element from which we are creating the grid. Now if it is a magic grid, we are simply doing answer plus plus, and in the end whenever this loop ends, we will be just returning our answer. Now the main thing is how will we check this a particular grid or a particular 3 cross 3 subgrid is a magic grid or not. This is the main thing. So let us see how we can check a particular grid is a 3 cross 3 a magic grid or not. So let us take this same example only. So let me just redraw this. So yes, I have redrawn this grid. Now we will check if this particular 3 cross 3 subgrid is a magic grid or not. So let's say we are checking for this particular 3 cross 3 grid. Our I will be here and j will be here. So this is the top left element by which we are creating 3 cross 3 grid by going 3 to the right and 3 to the down. So what is the first condition? First condition is that all of these elements should be unique elements as well as be within the range from 1 to 9. So what we can do, we can create a set or unordered set and we keep storing the elements and we will check whether this particular number has come before or not and it is within the range 1 to 9 or not. So what we can do, we'll be running 2 loops. Let's say k equal to 0 up till k is less than 3 k plus plus. Similarly, we can run a loop for columns, like let's say L equal to 0, L is less than 3, L plus plus. Now this is how we'll be iterating in this 3x3 subgrid. So we will check whether this particular cell, and how will we say a particular cell? What is this cell? This is the I, this is the J. So for this cell we are going one column plus and the row is same. For let's say if we are at this element, so how we are going to catch this particular element? We are going one to the down and one to the right. So we just need to add, or we just need to take this kth and lth element to check a particular cell. So we can, how we can check what is the value of this particular cell? The value of this particular cell is nothing but grid of I plus k, this is for the row part, and j plus l, this is for the column part. So this will be running in the loop, so we will be keep getting the cell values. 1 will be 4, then 3, then 8, then 9, then 5, then 1, then 2, then 7, then 6. So this is how we'll be iterating. So this is the value that we will get. Now what all conditions we need to check? Whether this particular value is present inside the set, whether this value is between the range 1 to 9 or not. So first we will check whether this particular value is like less than 1, or this particular value is greater than 9. If this is the case, that means it is not within the range 1 to 9. As well as if we have already found this number, that means this element is already present inside our set. That means set dot count of this particular value. If it is already present, if any of these three scenario exists, then we need to return false. Otherwise what we can do, we can simply insert this particular element into our set, this particular value, and move forward. Now this was the first condition. Now how we can check the second conditions, like the other conditions, the summation condition? That is also simple. Now this is not much to explain, I'll just show you how we can do this quickly. We will be able to understand with the help of code as well. So we will first create the base sum of the first row. So first row sum will be what? Grid of I comma j plus 1 plus grid of I comma j plus 2, because this is what we are doing. The I is fixed, we are just moving the j 2 more times. So sorry, this would be j, this would be j plus 1, and grid of I comma j plus 2. So this will be the base sum by which we will be comparing whether all of the rows, all of the columns, and both the diagonals have the same sum or not. So okay, we have one sum variable. Now how will we iterate over this row and column? Let us see. So how we can do that? So let us say we keep a key variable from 0 till 3 and k plus plus. So how we can do? For the row part, what we are doing? So actually for a particular row, let's say we are at this particular row. So when we are at this row, what we are doing? We are taking j plus jth element, j plus 1 and j plus 2. For this particular row, we are again doing j plus 1, j plus 1 and j plus 2. And how we are iterating in this row part? Let's say this is the ith row. So for this will be nothing but I plus 0, this will be nothing but I plus 1, and this will be nothing but I plus 2. So for that we are keeping the k variable which will loop through the rows or columns, whatever condition we are doing. So for the row part, we can say that our particular cell will be nothing but I plus k. In this case, the first case, the k will be 0, so we'll be iterating on this first row. In the second, when I is 1, so we are iterating on this first row. When k is 2, so we are iterating on this second row. And this will be the row, and what will be the column? Column will be simply j comma j plus 1 and j plus 2. So let us see, because for this particular row, what all elements we will take for the sum? This particular element j, this particular j plus 1, and this particular j plus 2. So let us see how we can write this. So what will be the submission? If grid of I plus k comma j plus 1, or rather we should start with j. Yes, j plus grade of I plus k and j plus 1 plus grade of I plus k comma j plus 2. If this sum is not equal to the base sum that we are taken, then simply return false. So this was the row condition. Similarly, what will be the condition for the column part? Again similar. Now we'll be doing I plus 1, I and I plus 2 for the row part, and for j we'll be iterating with the k loop. So if grade of I comma j plus k plus grade of I plus 1 comma j plus k plus grade of I plus 2 comma j plus k, if this is not equal to the summation that we have taken, then again return false. So this was the part for the row and column. But what about the diagonals? So let's say this is the 3x3 grid. This is the 3x3 grid. How we can get the columns? Let's say we have the top left element as this I comma j. So for this particular top left element, how we can get the two diagonals? This diagonal is simple. Simply do like I comma j element plus I plus 1 comma j plus 1 element comma I plus 2 comma j plus 2 element, because this is I comma j, this is I plus 1 comma j plus 1, and this is I plus 1 comma j plus, sorry, this is I plus 2 comma j plus 2. Now we need to take this particular diagonal as well. Now how will we get this diagonal? So first we need to get to this particular element. What is this element? This element is nothing but I comma j plus 2. So first we'll be starting from I comma j plus 2, and then we'll be going one step in the row forward, and in the column we will go backward. So one step forward in the row, so plus 1 I plus 1, and column backwards, so j minus 1 or j plus 2 minus 1, so it will be j plus 1. Again we'll go one step forward in the row, so it will be I plus 1. So let me just write like this. Yes, so I plus 1, and column one step backwards. So the previous column was j plus 1, so one step backward will be j plus 1 minus 1, that is nothing but j. So this is how we are getting this, both of these diagonals. This is the first diagonal and this is the second diagonal. So if after checking all of this condition, if we do not return false in between, so simply return true. That means this particular grid is a magic grid. So this was it about the implementation. So let us see the code now, so that you can understand in more better way. So yes, this is the code. So N and M is the row and columns for the grid. This is row and this is columns. So first of all, we are iterating to check each and every subgrid whether this particular subgrid is a magic grid or not. So we will be within this range n-3 and m-3. Why we have already seen in the explanation part. And for each and every subgrid, 3x3 subgrid, we are checking whether this particular subgrid is magic grid or not. If it is, we are incrementing our answer, otherwise we are not doing anything. In the end, we are simply returning the answer. Now how we are implementing this magic grid function, let us see that. So first of all, we are creating an unordered set to keep track of the unique elements, and then we are checking the condition whether we are between the range 1 to 9 and we have the unique elements or not. So we are running a k loop from 0 to 3 and L loop from 0 to 3. So that we can iterate on each and every row, so like each and every column, row wise and column wise. So if this particular cell, like what will be a particular cell, I plus k and j plus l. So if I plus k comma j plus l is less than 1, or I plus k comma j plus l is greater than 9, that means it is not within the range, so we will return false. But also if this particular element is a duplicate element, that means it has been occurred previously, so we will check whether this element is already present in set or not. So if it is present, that means it is a duplicate element, so then also we will be returning false. Now if this scenario is not exist, so simply put this element into the stack and move forward, set and then move forward. Now what was the other condition? The other condition was the sum condition. So we will take the base sum I comma j plus 1 and I comma j plus 2, and for this particular base sum we are checking all the row sum and column sum and the diagonal sum. So how will we do the row sum? Simple, I plus k comma j, I plus k comma j plus 1 and I plus k comma j plus 2. So this is the row sum. If I plus k comma j, I plus k comma j plus 1 and I plus k comma j plus 2 is not equal to the base sum, that means this row is not matching a base sum, so return false. Same for the column. For column what we can do, like let me just erase this. Column will be just reverse for the row part. I comma j plus k, I plus 1 comma j plus k and I plus 2 comma j plus k. So this will be the column sum. So if this summation is not matching the base sum, so return false. For the diagonals it is simple, just check I comma j, I plus 1 comma j plus 1 and I plus 2 comma j plus 2 for the forward diagonal. So this is for the forward diagonal. If this is not matching the base sum, return false. For the backward diagonal, first we need to go to the rightmost element, that would be nothing but I comma j plus 2. Then we need to go one step forward in row and one step backward in column. So what you can do, I comma j plus 2, then I plus 1 comma j plus 1 and I plus 2 comma j. If this is not matching the base sum, return false. And if all of this condition matches, return true. That means it is a magic grid. So this is how we'll be solving this problem. This was just an implementation based problem. So I hope you understand this problem. Thank you for watching.